application of AI, robotics, IoT, and cloud computing. So this session will be taken by Dr. Sunil Gorantiwar. So please allow me first to introduce Sir. Sir is head of Department of Agriculture Engineering, MPKV Rauri, Maharashtra, and he holds PhD and postdoctorate from Water Engineering and Development Center, Loughborough University, United Kingdom, under Commonwealth Academic Scholarship, and he has done his MTech in Agricultural Engineering subject from IIT Kharagpur, as well as BTech in the same subject from Dr. PDKV Akola. He has total experience of around 36 years in the field of agriculture engineering and has published almost 100 papers in national and as well as international journal, and has citation of more than 100 with H index 12. And apart from it, he has bagged many awards during his time span. So Dr. Gorantiwar has completed many externally funded projects which were funded by ICR New Delhi, Department of Space, GIZ Germany, and Ministry of Agriculture, Government of India. And currently, sir is principal investigator of Center for Advanced Agriculture Science and Technology for Climate Smart Agriculture and Water Management, which is in collaboration with Washington State University, US, Mississippi State University, Indian Institute of Remote Sensing, Dehradun, India, Kisan Hub St. John's Innovation Center, Cambridge, UK, and Climate Change, Agriculture and Food Security, New Delhi, and several other industry. So with this vast variety of experience, I humbly request Dr. Sunil sir to please deliver his experience, share his experience with us on IoT smart monitoring system. So yes. Over to you, Sunil sir.
Yeah, thank you very much, madam. May I know the profile of audience, means mainly student or?
Yes, sir. We have total 1100 registration, and these participants are from dairy technology, food processing technology, agriculture statistics, agribusiness management, extension, economics, and some people are from other non-agricultural background.
Okay. Thank you very much. Yeah. Just what I wanted. Yeah. Very good afternoon to all. And in fact, this is the second day of training, and this is the afternoon session. I hope all were able to join this session. And thanks to Preeti Madam for introducing me. And then I would like to share my presentation on IoT applications for smart farming. I hope I have this presentation right, sharing right.
Yes, sir.
Can you confirm me whether my presentation is visible in?
Yes, sir. It's visible.
Okay, no problem. Okay, yes. As all of us know that the title of this training program is on smart farming, and I will be delivering a lecture on IoT based smart farming system, and the duration of lecture is 90 minutes, 1 hour and 30 minutes. What I intend to do, maybe I will deliver this for about 75-80 minutes, and we'll keep some 10 minutes time for discussion if that provision is there, or or I can straight away also present for 90 minutes, no problem, depending on the situation. The topic is IoT based smart farming system. Okay. My presentation is structured in 6 parts actually. First is as the entire training program is on smart farming, so many of the previous speakers, they might have already covered smart farming and all those things, but then I would like to briefly present about the smart farming and also the need of smart farming in context of using the IoT based technologies and other technologies as well. Okay, as a smart farming word itself consists of the smart word, then there must be different technologies actually. But in third part, I would like to list out the various technologies to be leveraged for smart farming, and Internet of Things is one such technology. So which I will try to deal somewhat detail. I say somewhat detail because I find from the schedule that there were already 2 sessions on Internet of Things, and many of you already might have got the flavor of Internet of Things. Okay, most of my presentation will be on IoT applications for smart farming actually. Okay, so what are the different kinds of the applications currently which we are doing, and currently which other organizations, universities, they are also working. And the last and important part for the students is way forward, means how we can use IoT based technology for smart farming, because there are many students from agriculture faculties, and many times what happens from experience of our students, that when if they want to use any advanced technology, and particularly related to IT and ICT, there are certain reservations that many times they tell that this is my master's dissertation, doctoral dissertation, and at this level, how I can use these technologies, and how I can complete my thesis within the allotted time. Okay, but then there are several ways and means that will be discussing, and that is supposed to be useful for the students who are doing their master's or doctoral thesis. In fact, these IoT technologies doesn't have any do not have any limitation that only agronomy students should use, or only soil science students should use. The students from any background can use IoT based technologies to make the farming smart, and at the same time to make farmers smart as well. Okay. In fact, smart farming can be described in several ways. Okay, but then I have adopted this particular definition of the smart farming, which is the management concept on providing the agriculture with the infrastructure to leverage advanced technologies. Means basically, smart farming can be described or defined as the management practice or concept which provides the agriculture with the infrastructure that enable the entire agriculture to use the advanced technologies such as data analytics, artificial intelligence, Internet of Things, then many more such as drones, remote sensing, GIS, robotics, geoinformatics, and all other things. And this is for tracking, monitoring and managing, automating and analyzing various operations. Okay, all of us know that in agriculture there are several farm operations. Okay, it is not like any particular mechanical based industry that there are certain fixed operations and we can model those operations properly. But in agriculture, there are several operations, and the tracking, monitoring and managing of those operations also depend on the type of crop we are dealing with, type of soil, type of weather, and there are many more things. But basically, smart farming is the concept which enable us to use the advanced technologies that we are using in other sectors. Okay, such as AI, IoT, sensors, drones, robotics, and all those things. Okay, and that we need for tracking, monitoring, managing, automating and analyzing various operations in agriculture-based system. And you may wonder why we need to track and monitor and manage all those operations when anyway we are doing this. This particular question will be answered during the process of this lecture. Okay, and why we should do this actually. Okay, because when we say that, okay, smart farming is all right. Okay, so it enables us to use the different kinds of the advanced technologies. But why? Okay, so that question is also right, and the answer of this question lies in the boxes which I have presented on right hand side. Okay, smart farming enable us to enhance productivity, to increase our net returns, to improve our input use efficiencies, to reduce our emissions, then increase resilience, and also at the same time increase gender and social inclusions. Okay, smart farming enable us to do all those things together as well. Okay, but then you also may say that if we consider any particular modern technology in agriculture which doesn't include all this kind of the advanced technology also enable us to do or to address all those questions. But smart farming enable us to do this very efficiently, very effectively. Okay, so all these things we are going to cover in this lecture. But then in nutshell, you may understand, or you can remember smart farming as the concept which enable us to use all kinds of the advanced technologies, okay, for different kinds of the agricultural operations, including tracking, monitoring, managing, automatic, and analyzing, for increasing productivity, increasing net return, improving input use efficiency, then reducing carbon gas emissions, increasing resilience, and increasing gender and social inclusion. So these are the benefits of smart farming. Okay, and why the smart farming can do this is very important actually. First thing is that with the use of all these advanced tools, okay, smart farming concept enable us to practice the agriculture with precision. Okay, that is, it enable us to practice precision agriculture. This is very important. One may say that why precision agriculture is important. The reason is that agriculture is very complex system. Okay, agriculture consists of crops and various kinds of the crops, soils, various kinds of the soils, weather condition, farming operation. Okay, so all these are very complex. Okay, and the need of different inputs and response to these inputs in terms of the output is different for different kinds of the scenario. Okay, but we anyway practice agriculture traditionally, but in traditionally what we do, we don't consider this complexity and heterogeneity, and therefore we compromise many things. Say for example, traditionally if we want to apply water or nutrient or fertilizer, then many times we don't consider the variability in weather and soil. Okay, and in fact also we don't consider variability in crop growth as well. Okay, and most of our recommendations, they are based on certain criteria. Okay, certain kind of the recommended dose and all those things. Okay, so basically they don't consider this complexity and variability, but this is important, and this leads either to the over application of the inputs or under application of the inputs. If there is over application of the inputs, there is wastage and our input use efficiency won't be good. In case of the under application, then our productivity is compromised. Okay, so this is what happens in traditional farming practice currently that we adopt actually. But if we adopt the approach of precision agriculture, okay, then in case of the precision agriculture, we have to consider all kinds of the variability in terms of the crops, soil, weather, and management practice. And when we do this, then we'll find that the requirement of different inputs is different at the different locations. Its response is different. Say, for example, I have a farm of say 1 hectare. Okay, and traditionally what we do, that the kind of soil in the farm is maybe light or medium or heavy. Okay, so we do like that, and maybe the entire farm is gently sloping. Our entire application of input is based on this kind of the consideration. But even if we take 1 hectare of the farm, there is a lot of soil variability. We know that soil varies from location to location. So even the soil type is different at a location which is 100 meters from the previous one. Okay, weather condition also varies. Okay, then because of all those things, crop growth will also vary. Then we know that in case of the light soil, maybe seed rate is more. In case of heavy soil, seed rate is less. In case of heavy soil, maybe we need to apply more water at one time compared to light soil. So these are the things actually. And if we don't capture this variability, and without capturing this variability, if we try to apply the inputs, then as I told earlier, the application of input will either be under, that is less, or over, that is more. But in case of precision agriculture practices, we exactly capture this variability, and then we tend to apply all kinds of the input as per the need. So this is the precision agriculture. And when we apply all the inputs as per the need in terms of the space and in terms of the time both, then the response of crop to the application of this input is also more. So in short, with the practice of precision agriculture, we can enhance the productivity. We can also enhance the input use efficiency, and at the same time we can reduce the cost on the inputs, and we can reduce the farming cost. Okay, so this is good as far as this explaining is concerned actually. Okay, but in practice it is very difficult. If we don't have any aid of technology, it is most difficult to practice the precision agriculture approach. Okay, and it is even difficult to practice in our scenario where the farm holding is very less. Many of you must be knowing, they may be reading that in the countries like Brazil, Australia, USA, they adopt this precision agriculture. They apply the inputs as per soil type, as per weather condition. But then we must understand that their farm size is quite huge. Okay, so up to the order of 500 hectares, 1,000 hectares, but and with one crop, and then it is pretty simple for them. But in our scenario, it is very difficult if we consider our land holding and also the various types of the crops we grow on the smaller farms actually. Okay, so it is very challenging, and then we have to develop the different practices using the different kinds of the tools for making this precision agriculture approach in practice. And here there is the use of the IoT based technologies, or other sensors or other kind of the technology will come to our help actually. I tried to explain what is precision agriculture, but if we want to explain this properly, then it is a site-specific crop management practice based on observing, measuring, and responding to inter and intra-field variability. So on right-hand side, I have written the proper definition of precision agriculture. So precision agriculture basically is a site-specific crop management. Okay, and it is also the farming management concept based on observing, measuring, and responding to inter and intra-field variability. Intra-field variability means variability in farm, in field itself, and interfield variability means variability between field. So what we have to do in precision agriculture, first we have to observe the variability, and I have already told the variability in crops, soil, weather, management practices, and all other things. Then we have to measure that, and then we have to respond that. Okay, so there are three components, and maybe we can do with the help of traditional approach. So we can observe the variability. We know that at this corner of farm the soil is light, and at another corner of farm the soil is heavy. Okay, maybe measure, we can measure as well, but then we know that after observing, measuring is so difficult. We have to take the soil samples, take those to the laboratories, analyze, then know. So you know our entire crop season will be spent in just measuring the variability, and after that we have to respond as well. Respond means if light soil is there, then we have to apply inputs as per light soil. If heavy soil is there, we have to apply inputs as per heavy soil. Okay, so without the aid of technology or with the traditional approach, we cannot do this. Means we cannot observe, we cannot measure, and we cannot respond as well. Okay, so therefore precision agriculture though has been knowing since long, but as we don't have the right kind of the technologies, we are not able to follow the precision agriculture practice actually. But now all of us know that the technologies they have advanced at such a rapid pace during last 2 decades. As far as the IT based technologies are concerned, then we say that now anything is possible. So all these technologies that are being used in other sectors of development, we can also bring all these technologies to use in agriculture, and we can follow the concept of this precision agriculture. Precision agriculture has also many other advantages as well. Okay, so in short, what I want to tell you that precision agriculture means applying the right kind of the inputs at right place, and for this purpose we have to observe, measure and respond to the variability in crops, variability in soils, variability in topography, and it is very difficult to do this manually, and we need the different kinds of the tools, and IT based technology offer the different kinds of the techniques, and there are other advantages of precision agriculture as well. But when we use all these IT kind of the tools for farming, okay, then together we also call this as the digital agriculture, which I will cover later on. But then this precision, in case of precision agriculture, I have told you about the inter and intra-field variability, but at the same time there is temporal variability as well. Okay, another concept is that in case of precision agriculture, we consider the variability, but at the same time it is also necessary that we should consider the variability in real time. Okay, so precision management practice is now superimposed by the real time management. Okay, because though maybe soils they don't vary with respect to time greatly, but weather conditions and crop growth and management practices they vary with respect to time greatly. Okay, so as far as the precision use of the inputs are concerned, we need to consider the variability not only in terms of the location or space, but we have to consider variability in terms of the time itself. So for example, if I want to apply irrigation water today, then I must know what is the irrigation requirement today, and for that I must know what are the weather parameters today or few days preceding today. Okay, and for this, and this is called as the real time. Okay, so in fact with the help of traditional approach or without the aid of technology, real time management is not at all possible. Okay, so we need to have the precision agriculture coupled with the real time management. Now you know that how difficult it is to adopt this with the help of the traditional approach or without the aid of technologies. Okay, then I would like to summarize this in one or two sentences, just to emphasize and just to impress upon you the importance of this precision management and real-time management. Okay, as we have been knowing that over the years we developed so many techniques and technology and which enabled us to increase our production and at the same time to enhance our net returns as well. Okay, but at the same time nowadays what we have to do is that we have to also use the inputs with a great efficiency. We cannot waste the inputs because there are many concerns about this, because we know that our Honorable Prime Minister has also announced that we need to double the our farm income, and this is also possible when we reduce our expenditure on agriculture, and this means that we have to save our inputs actually. So in fact this is the preamble for this purpose, and for this purpose precision agriculture, where we apply the inputs exactly as per the requirement, okay, that is called as the site specific management, and coupled with the real time means we apply all these things as per the real time data, not the average historical data. Okay, and this is not possible at all without the aid of technology or with our just human interventions. So when and for that there are different technologies. Some of the technologies which are being used, I have shown you on the right hand side. It involves several kinds, say robots, then drones, then mobile applications, geoinformatics, cloud, sensors, and all those things. So when we use all these technologies together, then we call the agriculture as the digital agriculture. So digital agriculture combines the use of all this technology. Okay, so now we are slowly moving from our traditional agriculture to digital agriculture, and this is for smart farming, to make our farmers smart. Maybe our farmer in future, I won't say in future because there are many farmers now nowadays who are fully or partly adopting the different digital technologies to manage their farms, and they have all kinds of the technologies, that is GPS, then laser levelers, and variable rate applicator tractor. Some farmers nowadays, they are using drones, sensors, and mobile applications. Okay, but then we have to consider all kinds of the farmers, from the small farmers to marginal farmers to the large farmers as well, and we need to develop all these digital agricultural technologies for them. So with this view, our university, that is Mahatma Phule Krishi Vidyapith Rahuri, has taken one initiative in digital agriculture, and as a part of this, we have divided this digital agriculture into 7 sections. One is use of artificial intelligence and machine learning techniques. Another is robotics and precision machinery. Third is sensors. Fourth is Internet of Things. Fifth is mobile and web-based application. Sixth is drones, that is unmanned aerial vehicles. And the last one is geoinformatics, that is remote sensing and GIS. So these are the different techniques, okay, that aids us to follow the precision agriculture, to follow the real-time operation or real-time management, or in short, to follow the digital agriculture. And as you know that IoT is one such techniques. Okay, Mahatma Phule Krishi Vidyapith Rahuri has already one center for advanced agricultural science and technology. We call this as CAST, like Anand Agriculture University also has one CAST under World Bank aided ICR Nahib project. The title of our project is Climate Smart Agriculture and Water Management. Then we have one more project. It is RQA project, Irrigation Water Requirement Advisory Service. So I'm principal investigator of both the projects, and this we have combined both the project to form the Center of Excellence for Digital Agriculture, and along with the several activities of this our CAST project, our Center of Excellence for Digital Agriculture, we have established 4 laboratories which help our students, okay, to work on the digital agriculture. One is this unmanned aerial vehicle laboratory. Second is robotics laboratory. Third is hyperspectral imaging laboratory, and fourth is IoT and sensor laboratory. I think yesterday one of my scientists, Dr. Sachin Nalawade, has already elaborated on our AI, robotics, and drone initiative. And today I'm trying to brief about these IoTs and sensor-based technology. In fact, what is IoT? As I know that already 2 sessions were covered for IoT. Many of you, they have pretty good idea about these IoT technologies. Okay. In fact, when we say that IoT means Internet of Things, as I heard this Internet of Things word first time some 7 to 8 years ago, and that I heard from one of my student. Actually, I was his PhD supervisor, and he established one company in UK, Cambridge-based Kisan Hub, and he was trying to provide the advisories to the potato farmers in Ireland and also in Africa. And then when he came to India, then he told me that Internet of Things is something future and like this, but that time I didn't understand this properly. But then we further discussed, then we thought that it is having really great scope. But at the same time, if we want to develop these IoT based technologies for Indian farmers, a great amount of the work need to be done. And with this view, we started both the projects, and as a result of this, we also developed few of the technologies, of course, which I will present in my latter part of lecture. But before that, let us see what are the basics of Internet of Things. Okay, as I have mentioned here, Internet of Things describes the network of physical object things that are embedded with sensors, software, and other technology. Basically, why I described this precision, real-time, and digital agriculture, there you came to know that if we want to follow the practice of precision agriculture or digital agriculture, then we need different kind of the things. Okay, and it is not only that we need different kind of the things, but based on those things we have to take certain decisions. Those things need to be connected with each other. Okay, so when we connect all these things with each other, okay, but it is not just simply connecting, but while we connect all those things, then this connection should be able to exchange the data. Actually, this is very important through certain connections. So normally it is internet or other communications network. Okay, in layman language, how we can describe Internet of Things is that there are different things actually. Say computers are there, sensors are there, or our domestic devices, say air conditioner, fridge, and all those things are there. Okay, and connecting those things with each other. But at the same time, when we connect all those things with each other, this connection should exchange the data, which is prerequisite of Internet of Things. It is not just connecting all the physical objects without exchanging the data. So, and in this connection, it is not only physical things, but other things as well, such as software. Okay, so in that network of Internet of Things, the software is there. You know what is the purpose of software? Software analyze the data, provides us information, and if the software is intelligent, it also transform information into knowledge and decision making. Okay, so all these things are connected with the proper connection, that is internet, and we call this as Internet of Things. And basically, Internet of Things really connects the world with each other. Actually, the world has become smaller, not because of any other technology, but because of internet and Internet of Things actually. Okay, so if you have the IoT enabled technology, then you can virtually do anything in other corner of the world, and by doing that thing, you know all the things what is happening there actually. So it is very much possible. And in our day-to-day practice, maybe many of you may be adopting these IoT based technologies as well. Okay, the simple examples of IoT based technologies which is being adopted in our day-to-day life is, say, for example, operation of our air conditioners. Okay, our central cooling system. So wherein there are sensors which record the temperature, and this temperature data is passed on through internet to certain server, cloud-based server. Okay, and where this data is analyzed into certain kind of the information. Say, for example, all these sensors, they are giving the temperature data in the range of, say, 18 to 20 degrees centigrade. So that will be analyzed. Then there will be certain decision support system which will tell that, okay, if temperature is less than 24 degrees centigrade, then the system, air conditioner system, must be closed. And then depending on this information will be passed on to certain controller, and this controller will make system off actually. So everything is automatic here. Okay, because we know that maybe if we have set our proper temperature range as 24 to 28 degrees centigrade, okay, then to maintain that temperature, okay, there are all kinds of these things and devices which are connected with each other. They exchange the data, they analyze the data, and also they take decision, and based on decision, they also operate the system actually. Okay, so this is basically in layman's language this is the Internet of Things. Okay, so this Internet of Things is being practiced in many sectors of the development. In industry, it is being practiced, and not only to small extent but quite a great extent. And many of these industries, they are becoming automatic because of this Internet of Things approach. Agriculture is not that explored field as far as the application of IoTs are concerned. But at the same time, I would like to tell you that though it is not much explored, but there is great amount of the scope to develop IoT technology and to practice IoT based technologies. Therefore, the students, those who are thinking to use the advanced technologies for farming and also for making farmer smarter, then they can think of applying these IoT based technologies. And you can practice this IoT based technology virtually in any discipline of the agriculture. So with this definition of IoT, then why Internet of Things? I think I have already described in process of time. We can connect all the objects, take decision, operate the system remotely and automatically. So while doing this, all those things, we do this with precision. So we save labor, we save resources, then we optimize the environment, we optimize the productivity. And nowadays, again, by means of this cloud-based computing, big data analytics, and all those things, it has become more easy, because when Internet of Things also generate huge amount of the data, and it is essential that we have to analyze this data, and we need the low-cost computing and efficient devices to tackle with the huge amount of the real-time data. Okay, and as this is becoming possible, Internet of Things is also becoming possible. And as again I told you, this is the most important technology of this 21st century, and agriculture is no exception for this purpose. Then how IoT works actually, and again I'm sure that my predecessors, experts, they might have already covered that, but then in my own narration, based on my experience and based on the literature, I consider IoT has 5 major components actually. One is sensors and different kinds of the devices. Second is connectivity. Third is processing of the data, and also user interface is required, and certain activation devices. Okay, many times when the flowchart of IoTs or components of IoT, they are either described in 3 components, 4, or many other components. But as far as our farming and agriculture system is concerned, I think 5 of these components are very important, and we'll see also all these components one by one. Sensor is first component, which I have shown is required for collecting data. Connectivity is required for exchanging the data, because data exchange is very important. If we just go on collecting the data, there is no use actually. Then when we exchange the data, then that data must be processed actually, because you know that data information and knowledge that flow, you already know. Data is there are huge numbers are there, and we need to analyze all those numbers to obtain certain kind of the information, based on we can generate knowledge and take decision as well. Okay, and then user interface is required, because we are dealing with the agriculture system, or for any kind of the system. We need to know what is happening. Also, we need to have certain feedback, and also we need to provide certain details to the entire system, either to begin with or maybe in between. So for that, user interface is also required, and then certain kind of the activators and controllers, they are required to operate the system as well. Okay, so I will also describe all this with the help of example, but for the time being, the major components of IoTs are sensors, connectivity, data processing, user interface, and certain kind of the activation devices. Okay, now let us consider first as the sensors. Okay, sensors are devices, they are key components. Of course, all are key components, but sensors enable us to collect and obtain the real-time data from the surrounding environment at specified location at the desired time interval. Okay, the sensors are considered as the heart of the IoT, because it collects the data. Okay, with the help of sensors, we can obtain the data. This data is not just only one-time data, average data, but this is the real-time data and also the location-specific data. If we take, say, for example, the application of the nutrients to crop, okay, then maybe in this case we need the sensors, okay, that will tell us what is the current level of, say, nutrients NPK. Okay, that we should know current level I'm talking about. Okay, and also this is not at only one location in the field, because the field is having so much variability as far as the nutrient availability is concerned. Then we not only have to observe but measure that variability at different locations and also real time. Okay, so for that sensors are required. Okay, sensors are also required to know the water content in case of the irrigation management decisions. Sensors, they are also required to know other kinds of the abiotic and biotic stresses in case of pest and disease management and application of the chemicals based on the intensity of pest and diseases. Okay, so without sensors, it is very difficult for us to follow the practice of IoT, at least in agriculture. So we need to have the sensors, and this is one important component. Second component is connectivity. Okay, as I told, that means this nowadays, with the help of with the advance in this electronics technology, the sensors will record data at the desired interval. Say for example, if I want to record the temperature, this temperature can virtually be recorded every second. Okay, then it can be also recorded every minute depending on our time interval. But you see the huge amount of the data that is being available with the help of sensor need to be stored and also need to be processed. And for that, we need to transform this data to certain data processing unit. Actually, nowadays the cloud computing is talked quite a lot actually, and this is what is also required for Internet of Things. So for that, we need the connectivity. This connectivity is not only required to transform the data from sensors to cloud, but also back from cloud to the user interface and also activators and controllers. So connectivity is very important, and all the collected data can be sent to cloud infrastructure through connectivity like GSM, GPRS, LAN, Wi-Fi, Bluetooth, Ethernet, LoRa. So there are so many kinds of the tools available for seamlessly transferring the data from one thing to another thing. But that connectivity is important. So if you think of the world without this internet connectivity, and in fact, I will say that we cannot think of the world without internet connectivity. Okay, so the similar thing is true about IoT. The internet or connectivity is required. If this connectivity doesn't exist, IoT won't exist actually. Data processing. Okay, now this data processing is also important component. Many a times there are simple tools or simple what we call as the applications. A few of those I'm anyway going to describe, wherein we may not need huge data processing, but when it comes to really practice the precision agriculture approach, then we need to analyze all kinds of the data. This anyway, the sensors will record the data, connectivity will transform the data, but then this data is to be processed. So for this, we need very efficient, high speed, high storage computing server, and cloud computing is the buzzword today. And I'm of the opinion that all our agriculture science students must know this actually. Okay, because at least if we are not able to write programs, but we should know how it works actually to conceptualize our framework for any of our research topic. Okay, so once that data comes to cloud, then cloud-based computing will enable us not only to store the data, to process the data, at the same time to run certain software and decision support system. Okay, means this cloud-based computing will enable us various things actually. First thing is to store this data, converting this data into information, then at the same time information into certain knowledge, and then taking decisions. Say for example, with the help of temperature sensor, I am getting data say every 1 minute, okay, and which is being transformed or sent to through proper connectivity to data processing unit. There, this all kinds of the number will analyze us to provide the information that yesterday's our current temperature is say 24 degrees centigrade, okay, and then with the help of our software, this will get certain knowledge that whether this is required temperature, whether this is too hot, whether this is too cold. So that will know, that information is converted into knowledge and then into decision whether we really should live in the environment where this 24 degrees centigrade temperature exists, whether the 24 degrees centigrade should be increased or decreased, whatever it may be. So that is known as the decision taking. So everything everything is done in data processing unit, wherein it is not only process the data, analyze the data, convert data into information, knowledge, and decision. And for many times, for taking decisions, we also use the artificial intelligence and machine learning approach, because now these sensors collect huge amount of the data, and there is software as well. And many a times the software can be trained in such a way that maybe in future we may not need many of the sensors as well. Okay, so so that is the AI approach that can also be adopted. Then once that decision or knowledge we know that, then as that there should be certain interface through which we will know that what is happening. So there are certain mobile-based devices is the major interface in IoT. So we'll know that yes, there is necessity of shutting down the system because the temperature is too cold actually, or maybe we need to start the system because the weather is too hot. Okay, and then system can be developed in such a way that based on this decision it can be operated automatically. But at the same time, we in order to enable us to know this, and at the same time, not only to know this, but if we want to change something, depending on the current situation, or depending on whatever the protocol we have already given to the cloud computing. Say, for example, the situation is like that 24 degrees centigrade temperature is there, and we need to close the system, but we feel that no, it is all right, let us not shut down. Then maybe we can we can delay the operation, or we can have another threshold point with the help of this user interface. And one thing I forgot to tell you, that many times the mobile also act as the data processing unit as well. Okay, not for the bigger data analysis, but there are certain programs which we can develop resident in the mobile. So then in that case, maybe a cloud-based system is only used for storage and transfer of the data, and we can have a certain mobile resident program as well. The fifth, okay, sorry. Then user interface, anyway, I already explained. And the fifth is these activators or controllers, means whatever the decisions are taken, and based on those decisions, the different devices which are remotely installed must be operated, that is, must be stopped, must be started, or must be partially started, partially stopped, or whatever those things. So this kind of the activators and controllers are required actually. So the different kinds of the things are there. Say sensors are there, activators are there, user interface are there, softwares are there in terms of data processing, and all those things are connected with the help of proper connectivity. So all these things together form the Internet of Things. Okay, one such example I have explained. So all these 5 parameters, say for example 5 components, I tried to explain in agriculture system. Say for example there is a field, and we want to apply certain inputs, maybe anything, say water or nutrient. Then we need to have the sensors. So I have shown one encircled number, there are, say, soil moisture sensor, nutrient sensor, weather sensors, or NDVI, that is normalized different vegetation index. All these kind of the sensors, those can be installed in the field, so they will continuously measure the data. So that is first component. And if we limit ourselves, say for example, to the nutrient application, maybe nutrient sensor is there, so this data is passed through the communication network, that is two. This may be this is Wi-Fi actually, basically, but maybe through different means actually, Wi-Fi or GSM or GPRS or Bluetooth. Then this comes to either this cloud server or maybe mobile resident. But for the example, let us consider this comes in cloud server. There are different kinds of the software and decision support system, and some are also self-learning, such as artificial intelligence, machine learning, or artificial neural network. So once this data processed, analyzed, say for example, so it is say application of nitrogen is concerned, so it will our nitrogen sensor will sense the data, pass on this data to cloud server, then their data will be analyzed, and the application of, say, urea will be computed there, and then that is passed on to 4, that is user interface, and then maybe if we say okay, then maybe it will be applied automatically and remotely to the field. So this is the entire Internet of Things scenario in agriculture. Okay. Then as far as sensors are concerned, again, coming back to one, we need different kinds of the sensors. The first is the weather sensors. That is important because in any agricultural operation, we need temperature, humidity, light, then many times sound as well. Okay. Then we need to sense moisture in the soil, temperature in the soil, then vegetation indices, then different the different biotic and abiotic stresses of the crop canopy, and at the same time the different chemicals and nutrient contents. So basically what sensor does, sensor captures data from the preferred environment and transfer their physical properties, say such as whatever I told you, temperature, humidity, and all those things, into measurable electronic signals in binary code, because this kind of the information need to be transformed and processed as well. Okay, so this is what sensor does. It captures the data in the binary form. So this is the purpose of sensors. There are different kinds of the sensors. Connectivity, I already explained, GSM, GPRS, Wi-Fi, Bluetooth, Zigbee, LoRa, and there are other kinds of the connectivity. Of course, this also depends on the coverage, then battery life, and many other things. But then some sort of connectivity is required. Data processing, again, I told you that it is either cloud computing for big data analytics, but for the smaller application, we may have the web-based or mobile-based application, which consists of the software. Then again, user interface, either we may have mobile or web-based. All these web-based applications, in fact, anyway, already we have developed, and activators are controller that are required, and also for transferring this data and information, we need the embedded system, and at the same time there are different devices which are connected with each other, so we need the authentication. Say for example, say there are 100 sensors, and out of which the 2 sensors belongs to form A and remaining 3 sensors belong to form B, then we need to have the proper authentication. So that can be done with the help of QR codes with certain identification code. Okay, these are certain IoT hardware platforms, and I'm sure that some electronic experts might have already covered this. Okay, so with these certain basics of IoT based technology, I would like now to shift to the different IoT based technologies which we have developed, or there is a possibility of developing further actually. Now, why I need to emphasize here that there is certain process for developing the IoT based technology. So I would like to provide certain simple examples wherein you will get the flavor of how these IoT technologies works and also can be developed. So intentionally, I have given a very basic example. Now, the first example is, say, knowing evapotranspiration. Now, the students from agronomy background, soil science, or irrigation background, they know evapotranspiration, but I will take 2 or 3 minutes to explain what is this evapotranspiration. Okay. Now, when water is applied into the soil or onto the soil, either through rainfall or through irrigation in a crop field, some of the water will be evaporated from the soil and some of the water will be taken by the roots and will be transferred into the environment for the photosynthetic activity. So this we call as the transpiration. Okay, so together when we apply water to the soil, okay, either through rainfall or irrigation, okay, then water is lost in the process of evaporation and water is also consumed in the process of precipitation. We call this as the evapotranspiration. Okay, and why this evapotranspiration is important? Evapotranspiration is important for water management. Okay, because say for example, I am applying here, for example, 10 liters of water. Okay, and this 10 liters of water depends on the evaporation and transpiration need of that particular crop at that particular instant of time and at that particular location. Okay, because we cannot apply randomly any amount of the water. If we apply anyway, traditionally we apply these things, but then there is either under or over application of water. Then therefore, for determining the water requirement or irrigation requirement, we must know the parameter which is called as the evapotranspiration. Okay, then as I have shown here, this evapotranspiration depends on many parameters actually. Okay, first is the weather parameters. Okay, so temperature, humidity, wind speed, sunshine hour, and rainfall. So evaporation from the soil is governed by all these weather parameters, and at the same time, transpiration is also governed by these weather parameters. But at the same time, plant or canopy parameters also. What is the type of crop? What is the growth stage and all those things, and also soil, what is its fill capacity, wilting point, and bulk density. Okay, so evapotranspiration basically depends on many other things, many things actually. Okay, but primarily, if we want to calculate its reference evapotranspiration, that is the reference evapotranspiration of a particular crop, then there is one formula which we call as the Penman-Montier. So maybe again the agronomy or irrigation background students know this formula, but basically what this formula considers, this formula needs the data on location, what is the longitude, latitude, and based on this it calculates certain constants such as albedo, and at the same time it needs what is maximum temperature, minimum temperature, maximum relative humidity, minimum relative humidity, average wind speed, average daily sunshine hours, and if there is rainfall. These parameters are to be known, and these parameters are in fact, with the help of these parameters, there is one model, Penman-Montier model, one basic formula I have shown, but then there are several other calculations behind that basic formula. And if we put all these values in this formula, we get the evapotranspiration of the reference crop. Okay, so which is required for calculating crop evapotranspiration and water requirement. Okay, now when we want to apply water with precision, we must know this. Okay, and we know that all these weather parameters varies with respect to time, with respect to place as well. Say for example, temperature, maybe today is different, tomorrow is different, temperature at location A is different, location B is different. But traditionally what we do, we cannot do all those things, and then we don't do these things, and then we tend to apply the water just on ad hoc basis or on certain averages, resulting in under and over utilization. But what IoT enabled technologies enable us, this technology enable us to sense all these kinds of the data in real time and at the different locations, and fetch this data to cloud server, analyze this data, and then at the same time obtain this data. So basically our IoT based work started with developing this IoT based technology for estimating the evapotranspiration. So for this purpose, we developed one mobile application which we call as the Fulejal. This mobile application is in fact also acts as the computing device and also user interface. Okay, and at the same time, there are different means for collecting the data. That is component one, sensors, either AWS, not Amazon Web Service, automatic weather station, are the different kinds of the sensors. So that is the component one. Then component two is, of course, this GPRS or this our GMS. Then for three, processing the data, there is one cloud server or mobile also act, and for component four, the interface is mobile application or web-based as well. Okay, so this is the framework. So in this case, now this is the what we did actually. As far as the weather data are concerned, so we can have different kinds of the sensors attached to automatic weather station, which I have shown here. Then the second is we can obtain we can fetch the weather data from different services in real time, such as OpenWeather or AccuWeather, or IMD also provides nowadays this real-time FTP-based weather data, or maybe offline weather data, that is you can input yourself. So this weather data, all these weather data through connectivity is brought to the server, and then with the help of user interface, we can register our location and all those things. Then mobile application, the program here is resident in the mobile application, so it will analyze all this data which is obtained minute by minute or hour by hour basis into daily evapotranspiration, and this daily evapotranspiration value is known to the farmers or user actually. So if I know daily evapotranspiration value automatically in such a way, then I can base all the operations which require evapotranspiration data, because I know now this is the location specific and real time data. Earlier it was not possible, so this is only possible because of the IoT technologies. Because you see here, I have shown automatic weather station which is having sensors. All these sensors need to be IoT enabled in the sense that it should record the data and transform the data as well. So earlier this was not possible. You know that we are still using, say, ground observatory, so which don't have these IoT enabled devices. Then this data through connectivity is brought to the server and to the user interface, and then the computing is done. Okay, so this we can also do with the help of web actually. Okay, this is the web-based service as well. Okay, so I have shown you the mobile resident program, and we have also converted that into web-based program. The similar thing is there. That is, instead of mobile-based user interface, there is the laptop-based user interface or computer-based user interface. The other things remain same. Now, outwardly, this looks very simple, but when we started, we struggled quite a lot. But then anyway, we came up with the simple tool which tells us the evapotranspiration, and based on this later on, we develop many other tools. Now, those who are not having this particular water management agronomy background, they may wonder why this evapotranspiration is such an important, but then that's why I'm trying to explain you another tool that we have developed. In case of irrigation, normally there are three questions: how to irrigate, when to irrigate, and how much to irrigate. And out of which, how to irrigate means the irrigation method actually, whether we should apply water by surface, drip, sprinkler, subsurface, and so on. But when we decide the irrigation method, then when we should apply water and how much we should apply water is really the concern actually. In efficient irrigation management, we only nowadays address one question: how actually, by switching from surface to sprinkler, sprinkler to drip, drip to subsurface drip, and so on. But if we consider any of these irrigation methods, we really don't address two questions. That is, when we should apply water to the crop and in how much quantity. Okay, that we are not able to address properly, or even if we address properly, it is based on historical data. But with the help of these IoT based technologies, which collects the data which is location specific and at the same time real specific, with the help of different kinds of the sensors, then communicate this data to server, computing is done, then at the same time, we can see the result, that is if we have to irrigate every day or maybe once in a week, and if we have to irrigate once in a week, we should operate the system for 2 hours or 3 hours. Everything is nowadays known to us with the help of this IoT based technology, and we are able to apply water with precision. Now, this is one such example. The similar thing is there, only for knowing when to irrigate and how much to irrigate. We should know evapotranspiration, and at the same time with along with evapotranspiration, we need crop data, soil data, and other system data. I don't go into detail of this, but if we couple all this data, okay, then it is possible for us to know in real time by considering all kinds of the complexity and variability in crop soil, when to irrigate, and if if our farm or crop is to be irrigated, for how much time we should operate the pump. Okay, so in fact, this is now obtained in real time up to this. Okay, then this is also we can have instead of mobile, web-based as well. Okay, now the fifth component was missing. So while I was explaining this, I focused on 1, 2, 3, 4, but the fifth component is activating the system as well. Okay, now this is the complete IoT based system for irrigation management for the small farms actually. Okay, so if there is automatic weather station installed nearby or on the farm or in the village, or if not automatic weather station, if IMD FTP protocol is available, then if it is fetched, then what is done here, this weather data or IMD data or any other service data is fetched with the help of this connectivity to our cloud server, then to our mobile resident program, and there it is calculated whether the farm is to be irrigated today. If not, then the message is passed on, or the system, that is irrigation system, is not operated. If it is to be irrigated, then it will also tell us the pump is to be operated for 2 hours or 3 hours. Then message will go to the pump, that is the component 5 through the controller, and pump will be made on, and my drip or sprinkler irrigation system or surface, whichever maybe, will be operated automatically for the desired duration. And while doing this, there is always two-way feedback. Say, for example, the water level in the field has gone down below footwall, or maybe there is electricity off, and in case of such dry run, the pump will be stopped, and when the condition is fulfilled, the pump will be automatically on. So this is entirely automatic, remotely operated, IoT enabled scientific approach of water management, and this is only possible because of these advanced techniques. So here you can see now all the components. The sensors in the form of weather sensors is one, then there is connectivity, that is 2, then there is cloud 3, mobile 4, and the controller 5. So in this case, the farmer need not to do anything, and still farmer can apply water with precision. So this is one complete our irrigation scheduler. And the second one is that if my farm is small, so this is fine. But if my farm is large, then I may be having more than one crop in the field. Then in this case, I need to have the valves which are also IoT enabled, in the sense that if I have, say, 4 crops which I have shown here, maybe one is wheat, another is onion, third is cabbage, and fourth is sugarcane. The irrigation scheduling for all these 4 crops is different in terms of when to irrigate and how much to irrigate. So in this case, if today only wheat is to be irrigated and onion is to be irrigated, only the system should be operated for the desired interval of time only for these crops. So we need the IoT enabled valve for this purpose, so that the information should be passed on to these valves to start or to stop these valves actually. So this system also is completely IoT enabled, and this can be very well developed by the agriculture student in collaboration with, of course, certain electronics expert. Okay. And I have explained you 4 kinds of the IoT enabled system. One is just for calculating evapotranspiration, one was mobile based, and second was web based, and the third and fourth were for deciding when to irrigate and how much to irrigate. One was mobile based and another was web based. But all these systems required us the weather sensors. So I have shown these weather sensors. Then we have procured the meteorological grade weather sensors, converted those into IoT enabled in the sense that recording the data and transmitting this data. And also we developed our own admin dashboard, so wherein we can register all these automatic weather stations and make available these automatic weather stations to different farms. In that process, we have developed 6 ranges of the automatic weather stations ourselves. So these are the examples, and these are IoT enabled. And we also have in the process cut down the price of this automatic weather station almost by half, but still maybe small farmers may not afford to have these automatic weather stations. So for that, we have developed the low cost automatic weather station, which just cost 4,000 to 5,000 rupees. So to apply this entire IoT enabled system for irrigation for small farmers who may not need a wall, say 5,000 rupees for this and plus 7,000 rupees for the controller. So together the farmer can start, stop, operate system from anywhere remotely, and also more importantly on the scientific basis, that is by capturing all the real-time data, analyzing the data as per the need of crop, soil, and irrigation management system. Okay, similar thing we did about the fertilizer application as well, fertigation. Okay, so we call this as full fertigation scheduler. So wherein the real-time data is connected, and the currently this NPK requirement only is calculated in real time. And the fifth part, that is application part, is currently under development, wherein we are starting to develop the IoT enabled device for applying fertilizer, that is Venturi. This work is going on, so that the fertilizer application will also be entirely IoT enabled. Then whatever I have told you regarding irrigation was, say, weather based. Then it is also possible to develop the system based on sensing the moisture content in the root zone. And for that, we have to develop the sensors. We develop several kinds of the sensors, which I have shown here, bottommost circle. When we install these sensors in the field, they record periodically the soil moisture in the root zone of the crop. Then this is being transferred through the cloud. Then that is being analyzed. And then based on the soil moisture content in the root zone, whether the crop is to be irrigated or not, it is decided. And if it is to be irrigated, then the pump will be operated for the desired time operation. And entire thing will be done by the program, which is resident partly in cloud and partly in our mobile actually. So in this case, basically what happens, farmer need not to do anything. Farmer has to only install the sensors. The data will be captured automatically, analyzed automatically, and the system will be started and stopped automatically. Okay, so for that, we have developed ourselves for different kinds of the IoT enabled sensors based on the principles of resistance, capacitance, then capacitance and FDR combination. Then we develop other IoT enabled system as well, because once we grasp the concept of this IoT enabled, then we can do many things. For lifting the water from the farm pond automatically with siphon without any energy, we have developed this IoT enabled system, because farm ponds, they are located remotely, and farmer has to go to siphon the water from the farm pond every time, which is not possible. So we have developed this IoT enabled system, and also it is connected to drip irrigation. Then we are, along with the IoT enabled weather station, IoT enabled soil moisture sensors, we also developed IoT enabled tan evaporimeter to know the tan evaporation. We also developed the IoT enabled trench water level recorder, which is required for knowing what is the amount of water harvested, consumed. Then certain research tool, IoT enabled infiltrometer, IoT enabled hydraulic conductivity meter. And for IoT enabled solar power greenhouse or shed net house, this is still at the conceptual level. We have planned for the development. Besides that, this I have told you the simplest devices, but besides that, there are many other things which we can develop as IoT enabled, such as variable rate tractor, wherein the variability will be mapped, then captured by the tractor, and accordingly tractor will apply the fertilizer into the field. I'm sure that yesterday one of my scientists, Dr. Sachin Nalode, has explained this, and I think my time is also coming to an end, 5 or 10 minutes. So I switch to another topic, which I think the student will be more interested. That is, one is on the process of development of pest and disease management advisory system, where there is huge scope in doing that actually. Okay, so this can be done in two ways. One is just identification of pest and diseases, and on the basis of identification of pest and diseases, then what kind of the chemicals to be applied. And the second is the forewarning of the pest and disease. So these two things can be done, and it has very huge scope actually. In case of the identification, we have to build the images or the libraries of the images of the different kinds of the pest and disease on different kinds of the field actually. So that itself is a very huge task that we call as the library. And once we have the library, then we can develop the AI and sensor based tool, wherein real time, if farmer just scan that tool through his or her infected plantation, then real time image will be matched with library image through AI based model, and will know that what kind of the pest and disease is occurring, because library image is always tagged one, and with that tag we know that this kind of the plant is affected with this kind of the disease. And once we know that plant is affected with this kind of the disease, and we will also know the intensity of this disease, then with the help of decision support system, we will and other environmental parameters will know the measures to be taken. In fact, many universities have started this kind of the work, but this is probably the future line of work for many of the students. This is for identification of pest and disease, and at the same time providing the advisories to the farmers on the basis of intensity and type of the pest and disease. So this is one thing. And another important, and anyway, there are many companies which are coming in this particular field, but basically they are struggling with two things. One is building the library, where there is a role of the agriculture universities, and the fourth, I have shown here 4 compartment, and fourth issuing the advisories. Okay, and there are several industries which can help us to build the AI based model actually. So if we have proper university and industry collaboration with involvement of the student, it is quite possible that for each and every crop we can develop such kind of the partly IoT enabled tool, which will be helpful to us for identification of the pest and disease. The second important thing is that forewarning actually. Okay, so there are several weather based forewarning model actually, but those are not that useful, because it just considers the weather data, and we find that there is a lot of error actually. But if we use the certain vegetation index, or finding out the abiotic stress response with the help of hyperspectral images, then it is very much possible. The images that we observe with the help of our naked eye and images that is captured with the help of hyperspectral imaging, there is a difference actually. If certain pest or disease is going to be developed, then if we take continuously hyperspectral imaging data, then its development is captured few days in advance. And if we go on taking such kind of the images and build the library, then by using the similar concept in real time, so we will know the occurrence or pest and disease, say maybe few days in advance, and then we can have all kinds of the preparedness measure. So this is one of the researchable area for capturing biotic and abiotic stresses by capturing the plant images either with the help of RGB camera, that is what we see with the help of our eyes, or with the help of hyperspectral imaging camera. Okay, and then developing the tools wherein at least we know what is happening and what should be done. And if we couple this information either with the help of certain IoT enabled robo or IoT enabled tractor, then entire thing can be done automatically. I think part of this was already covered by Dr. Sachin Nalode yesterday, who is one of our team members as well. Okay, so I think it is almost 21 past 3. I would like to remain here for responding to any queries from your side. Thank you very much.
Thank you very much, sir. Your session was actually very much clean and helpful for all of us. And it is very good to know that your team is also working in this IoT and robotic parts. And we are very much interested in the deep engineering part if you want to associate with us also. And you are actually discussing some of the, pest and disease identifier. We are started working on IoT devices, and we have started working, means it is yet in the ideation period, because we have developed some AI and ML model for detecting those disease, but yet to deploy those models into IoT devices. So in this regard, if your team is working in MPKV Lowry, so we would like to associate with you, sir.
Yeah, okay, no problem. In fact, this capturing these biotic stresses and making entire thing IoT enable is quite a huge task, and there need to be collaborative work, and we need to build a team which consists of various kind of the scientists, and the same thing is true about this identification of the nutrients, because the sensors for this purpose which are available in market, they are expensive, and we need to develop those sensors. I think let us work collaboratively, and also let us work with the help of students, because we need huge manpower for building the libraries and developing the tools. It is good that you have started. We also have started, and let us exchange our ideas, concept, and work together. Maybe we can have a separate workshop on deciding the strategy on this. Thank you very much.
Yes, sir. Sir, can we take a question from the audience side?
Okay.
Yeah. So, sir, first question is, how many team members there to develop this system?
I'm reading this question actually. In fact, I told you that we have started this task with the development of small mobile application to begin with. Okay, then with the advent of technologies, we also improved our tools actually. Okay, initially we developed certain in-house applications. Okay, and with a team of research associates and some student actually. Okay, and I cannot tell exact number, many team members, because there are several other applications as well. Okay, and then we started. And there is one question regarding outsource partner. Yes, because you know that we work in the agriculture system. Okay, so we developed up to the software and up to decision support system. Okay, but for some of the applications, to convert that into Android based tools, okay, we had to outsource some part actually, and in some cases our students also did that.
Okay. Sir, next is for technology development. What is your opinion about using native app instead of building new one from scratch using services that already available?
No, one thing is that we never should reinvent wheel actually. That is one thing. So whenever you want to develop anything, so we need to have review of this. Okay. So first thing is that we should know what we need actually. And if we know what we need and if it is available, then there is no need of developing itself. But if there is what we need is not available, then exactly what we should develop, exactly where you should improve upon these things, all these things you have to decide actually. This is not just simply one day work, and that's why there is review, not only review of literature, review of all kinds of the development, and based on this thing we need to develop. But let me tell you one thing, that these IoT enabled tools, okay, they have been started very recently, and there is relatively good progress as far as the water related tools are concerned. Okay, but then for other, there is plenty of the scope, and I think we need to develop the new tools. But many times what happens, this is not only a single technology. As on screen you see that we need several kind of the things. Okay, maybe in case of pest and disease management, as maybe IT industry is quite well ahead, there are many companies who have developed already AI enabled matching, AI tool for matching of the images actually. Okay, that may you might also come across. But then there are left and right hand portion, that is building up the libraries, then tagging the libraries, developing the mobile applications to connect it to the AI based tool, and then preparing the advisory platform. All these things are not yet fully explored, and based on this advisory, then operating our application system is not yet developed as far as the nutrient and chemical application are concerned. So maybe tagline is that don't reinvent the wheel, but if you need something and if it is not developed, you should never hesitate from trying actually. You should go ahead with that.
Yes, sir. How much this technology transfer can be deployed anywhere or not? Means,
you know, this thing is that all these technologies capture the data real time and location specific from sensors. Okay, so it has good amount of the portability and transferability. So this is always the benefit of the IoT enabled technologies. It doesn't rely on the historical average or certain heuristic parameter, but real time and location specific parameter. Okay, so in fact, this is one of the strength of the IoT enabled technology. This is because of the sensors that collect the real time data.
yes, yes. What happened to farmers who don't use smartphones and do not have internet connectivity? App is it available on local language as well?
Yes, some of our apps, they are available in local language as well. So this is one thing, but the main question is regarding the internet connectivity. Okay, our farmers doesn't have a smart app. Okay, that is really a question. If because you know that when we develop any kind of the technologies, there should be inclusiveness in the technology, but at the same time it shouldn't hinder us in developing the technologies for others as well. So for that, what we do whenever we develop the technologies, okay, then we develop in both the languages, okay, or at least we keep the provision, because you know that ours is the university, not any commercial organization, but then we are trying to commercialize this technology wherein our partner will convert all those things into other languages as well. Say for example, there was demand from Andhra Pradesh to have full irrigation scheduler in Telugu language. Then anyway, so we can't do that because ours is research organization. So we did develop the tool, but then we are trying to do this with the help of roping one partner actually. So this is one part. Second part is for the farmers, those who don't have any internet connectivity, but then there is our local extension mechanism wherein we reach to each and every farmer. So for that, we also develop the web-based tools actually. Okay, in the sense that there are certain extension services, state government, KVKs, university services, which anyway reach to the farmer through SMS or through messenger. Okay, so wherein in case of the web-based, we make the provision that the KVKs or any farmer organization can build the record, which is which is built in mobile application anyway in web. So all kinds of the data and all those things, they are fetched in web portal, analyzed, the results are obtained. Only thing is that if it is to be conveyed to the farmers, as farmer is not having Android based mobile, then the certain messaging services is required there. But then we do at most to possible to address the situation of the farmer who doesn't have this kind of the things actually.
Which sensor you are using to collect data related to ammonia, nitrate, phosphate, alkalinity?
Yeah, in this case, somehow we got hold to for nitrate and phosphate, and as far as pH and salinity, there are several kinds of the sensors available. We are not using yet ammonia or hardness sensor, but anyway, so if we want to develop certain IoT enabled devices, first thing is that you don't reinvent the wheel, find out in the market whether this kind of the sensors are available and suitable, because as far as the nutrients are concerned, we found that many of the sensors which are available in the market don't provide us the available nutrient status which is required for determining the fertilizer quantity. So make sure that this is available. If not, then you should work on development of the sensor itself actually, because, and of course in partnership with the industry or certain other university which is having strong electronics and telecommunication department. Okay, so development of the sensor itself is one researchable area. Many time what happens that we try to enter into very relaxed domain actually. So again, sensor is available, this thing is available, then approach certain vendor and connect and tell others that we have developed this. Okay, but development of the sensor itself is very important things actually. Okay, so because we know the system, and electronics people, they know how to obtain the data and how to convert the data in digital form. Okay, so first thing is that if you don't have sensors, go on developing the sensor itself.
Yeah, sir, please throw some more light on how to build geo-specific, crop-specific spectral library. Spectral library source like USGS are available, but I need native.
Yes, for that, developing spectral library is very important and very huge task as well. Okay, so that's why there are many companies and organizations which already have AI-based tools for pest disease identification, but then they don't have the proper library, and that is why those tools, they are not coming into the practice actually. Maybe your university has also come across with such thing, but then we need to support them. Okay, and for that we need to develop the spectral library or RGB library. In case of the spectral library, you need to have, first thing is that the hyperspectral imaging camera, which is the essential requirement. Okay, and then you conduct the controlled experiment and go on taking the periodical images with the help of hyperspectral imaging camera, tag those, okay, and build your library. Say for example, in case of any pest, in case of any disease, if you want to develop, then periodically you need to take the observations of the affected and not affected plants and canopy as well. And as you are taking the observations, you know what is the level of infection and what is the kind of infection that you have to record separately. Once that is done, then you have to tag the hyperspectral image with the help of the level of infection and type of infection. So that is known as the tagging. So in this way, you go on taking the images after images, and then you will develop the library actually. So once you develop the library, then you can use this AI-based software and software actually. And our library will not be prepared in overnight. Okay, so it takes time. And once you develop the library with sufficient amount of the images, you start using tool. Then at the same time, you start strengthening your library, and also with the help of strengthened library, you try to refine and validate and calibrate this tool. Actually, this is quite ongoing kind of the process. But then for developing your own library, you need to have your own hyperspectral imaging camera.
How is overall experience regarding the adoption and using this web portal and application by the farmers?
Overall experience is quite encouraging as far as state of Maharashtra is concerned, and there are many adoption as well. But at the same time, we have to do a lot of extension work in this to convince the farmer, because for any time, because for any new technology, there are no immediate takers actually. Okay, so farmers always learn themselves. Also, farmer learns from the experience of others. Okay, so that is again the process which will go long actually.
Yeah. Sir, I think I have covered almost one question by the participant side. And sir, our PI, principal investigator of this project, Dr. Arish Pundir, is also in this room. So Pundir sir, would you like to say something to Dr. Sunil sir? He is also PI in the NAHEBCAS project in MPKV Rauri. So would you like to say something, sir? Pundir sir, please mute yourself. Unmute yourself.
Yes, Preeti. Dr. Gorantiwal, first of all, my good afternoon to you.
Thank you very much, Dr. Pundir Saab. After a long time, at least we see.
Actually,
so don't meet.
I was waiting to have interactions with you, but it is online, and definitely it is not sufficient for us. So the Preeti has asked some questions based on which have been collected, as you know, online systems from some of our the participants. Some basic questions, some very, very important questions he has asked. And Dr. Gorantiwal, you know, this is the most important area, rather sought after area today in agriculture. But we are very much at the nascent stage.
Right,
so
right.
I'm not a technical person in this area. We have very little understanding, though Preeti and other team members, they are doing some good work in this area. I have one basic questions towards you, and I hope that you will definitely throw some lights for the benefits for particularly of our projects abroad.
Okay.
Actually, let me tell you what this is basically meant for productivity and eventually profitability of the farmers, or making the farming as more profitable. But so far, this technology, which is very much at the nascent stage in our country, only few centers are doing, few companies are involved. Very, very important from production point of view, productivity point of view. How to link it with the market? This is again a very important question. Can you help us in identifying some of the farmers where we can see with the help of some farmers, some changes in the productivity, and eventually we can know the profitability kind of things, and we can take up some projects, or some students can be given some projects, maybe MSc students, 3 to 4 months projects, because at least towards Gujarat, we don't find such students much, and you are doing good work. So can you suggest something how we can do some project work, mainly for PG students, wherein we can see some benefits in monetary term, as well as we can link this, we can link the significance of this technology. We are talking very much with the market, with the prices.
Yeah,
so very generic.
Yes, thank you very much, Dr. Pundir Saab. Actually, I know that your Center of Excellence is on market intelligence, and this was quite widely acknowledged at NAHEP level that one of the centers is working on very important topic of market intelligence. Actually, in fact, I also know that whatever we are doing addresses the scenario up to production level. But beyond that is also very important, actually. Okay, I will answer your queries in two parts. One, as a part of our activity. So what we are doing, we have developed the concept of climate smart digital village, actually, and with the help of our alumni association, because you know that these are our tenurial project, and there should be sustainability beyond the period of this execution. With the help of alumni association, we are propagating, means we have developed the concept, we are propagating the concept of climate smart digital agriculture village, wherein up to this, the farmers, they are adopting the technology currently at pilot level. But then our target is that each and every farmer should adopt this, and this is going on actually. Okay, but then we are also developing the platform wherein we can connect the farmers' data with the market actually. Okay, but somehow this is only halfway through, because you know that a lot of human resources are required for this. But I think developing this platform, okay, wherein we can connect the data of all the farmers on the single platform, okay, analyze those and link it to the market actually. Okay, and then work on the market intelligence. Maybe at some other time, I will explain what we did till now. Okay, and maybe beyond that, you can continue, or we can continue together to provide the information to the farmers in terms of what is the market availability. Not only that, when we were discussing with the farmers, then farmers told us that we need the information. He told that this is all right, you are developing the technologies and all those things. First, you tell me that whether I should grow this crop or not. This is especially about the onion actually, because you know, in case of onion, there are a lot of fluctuations. Why don't you develop the system wherein I should grow this crop or not? For that purpose, we are developing one platform wherein the farmers should, in fact, input the data whenever they are cultivating for particular crops, and it should also be coupled with the remote sensing. And we know the requirement, and once that requirement is satisfied, we should provide the yellow alert to the farmers. Now stop sowing or planting of this particular crop, because already the potential or target has been achieved. And if you do this beyond this limit, maybe you won't achieve much. And then maybe after few more hectare or acreage are added, red levels. If you go now beyond this level, okay, maybe now there will be glut in the market and you won't get anything. So in fact, we had started this, but then again, because of the human resources and other priorities, it was not possible. But this is one kind of the platform I think your center can undertake. If you have already thought on this, good. If not, maybe I will suggest, because that is really a farmer's need. This would link our productivity with the market requirement, and this will really advise the farmers whether to cultivate or not cultivate. Okay.
Oh, yes.
Right, that is fun. It's excellent, sir. Yes, sir, you were expecting. Sir, from my side, this is one, but sir, we'll be in your touch and we'll be having more discussion on this issue. Very important. Yes.
And from our side, we extend invitation to you and your team and your student to our university to discuss, and maybe at some opportunate time we can discuss on some other platform regarding what you are doing as well, and see whether we can also contribute to that.
Definitely, Professor Gontawar, definitely we will do that, and this is very, very important for all of us, to you, to us also. Thank you, sir, for this much of kindness, and also we very much appreciate not only this content as a maybe the researcher par excellence, and we know that your center is doing excellent, and we are knowing these things not only from NAHEP officers and our DDG and others, but also we are knowing not directly from you. So, okay, sir, we will be in touch, sir, definitely.
Thanks a lot again for giving me opportunity to use this platform. Thanks a lot.
Thank you, sir. Thank you very much. We will definitely connect with you in future with our team, and thank you for making time for this particular lecture. And we are ending this technical session here, sir. So, dear participants, we will come for another session tomorrow. About foundation of AI and deep learning, and apart from it, some embedded system lecture you will also going to listen tomorrow. So we will connect tomorrow at the same time, 10 p.m. Indian Standard Time. And for today, see you tomorrow. For today, this is going to end right now. So good day.
Yes, thank you very much, Puddi Saab and Madam. Thanks a lot. Okay.
Thank you, sir.